Alright, let's get going here on your review for combinations, composition, and inverse functions. For the first one, we're combining f plus g. So all I'm going to do is take f and take g and add them up together. And then from there, all I'm going to do is combine like terms. So I have 1x squared, that goes away now. I have 5x's total, so those can go away. And I have 5 units, x squared plus 5x plus 5 as my answer. For b here, x minus h. Here's where we might have issues. We'll have 2x plus 4, that's f. Now I need to subtract h, but I need to subtract all of h, x squared minus 6. So that means I have 2x plus 4, distribute this minus x squared plus 6. So I should have negative x squared plus 2x plus 10. Now, if it was just f minus h of x. Because it's a 4, I'm going to plug in 4 here. So I'll have negative 16 when I plug in 4 squared, plus 8 plus 10. That means I should get an answer here of 2. Now my other option, I could have done f of 2, f of 4, and then minus h of 4. If I plug in f of 4, 2 times 4 is 8, plus 4 is 12. H of 4 is 16 minus 6, which is 10. 12 minus 10 is 2. So that's 2 different ways that you can solve really any of these. Okay, number 3 is, again, one that's straightforward. What I'm going to say is this is the same as g of 4 times h of 4. If I plug in g of 4, this will become 16, plus 12, which is 28, plus 1, which is 29. And then h of 4, when I plug that in, well, we just did that. We have 16 minus 6, which is 10. So I get 290 as my answer. Alright, same thing over here. Because I'm doing a number, I can actually just do g of 5 and then divide it by f of 5. When I do g of 5, 5 squared is 25, plus another 15 is 40, gives me my top of 41. For f of 5, 2 times 5 is 10, plus 4 is 14, so 41 over 14. Now we get into the meat and potatoes here. We're doing the composite function. So we're doing g composite f here to start. And what we'll start with g composite f, we're going to start with the inside function, so f of x. And that function, f of x, I'm plugging into g. So anywhere I see an x in that g of f, I'm now going to plug in that. So this is the same as saying g of f of x, which is 2x plus 4. So when I do that, g of x is x squared, but I don't want x anymore, I want 2x plus 4, that whole thing squared, plus 3 times the quantity, 2x plus 4, plus 1. To simplify this 2x plus 4 squared, that's the same as saying 2x plus 4 times 2x plus 4. So now I have to FOIL that. That becomes 4x squared. I'm going to have, this should be 8x and 8x, which is 16x, plus 16. I'll distribute this guy as well. I get 6x plus 12 there, plus 1. And now to simplify it all out, I should get 4x squared, I should have 22 x's, and I should have 29 for my units. Alright, continuing forward, looking here at number 6 here. F composite h. So same thing, except h is my inside function, I'll now plug that into my function for f. So f my outside, 2 times the quantity, because we now want h in there, so x squared minus 6 plus 4. Simplify that to 2x squared minus 12 plus 4, so that should be 2x squared minus 8 as my answer for letter F. Alright, down to the home stretch here. Looking at letter G, again, we're going to start with the inside, h, and then go into f. Now this one we have a number, so I'm going to start with h of 4. Again, if I plug in 4 here, 4 squared is 16, minus 16 is 10. So it means I'm now going to look at what f of 10 is. F of 10, meaning I'm plugging in 10 here, 2 times 10 is 20, plus 4 gives me 24 as my answer. Same thing down here, h of g of 1, start on the inside. G of 1, when I plug in 1, 1 squared is 1, plus 3 times 1 is 3, so 1 plus 3 is 4, plus another 1 is 5. So g of 1 is 5, so now I want to look at what h of that number is, what h of 5 is. So 5 times 5, 25, minus 6 gives me 19 as my answer. And then finally, this last one, This is a combination type problem. First, if I do f plus g of 1, that's the same as f of 1 plus g of 1. And I also have minus h of 4 over here. So, let's look at each one. F of 1, 2 times 1 is 2, plus 4 is 5. Actually, no, it's not. It should be 6, if I can count right. 2 times 1 is 6, plus 4 gives you the 6. G of 1. We just did that over here. We got 5 for that when we plugged in G of 1. And then H of 4, which we've done a couple times before now. 4 squared is 16, minus 6 is 10. So 5 plus 6 minus 10 gives me an answer of 1. Alright, let's look on here to finding inverses algebraically. The way we want to do this, we need to do two things for each one. We need to do f of g of x, and we need to do g of f of x for each of these. So, start with g of f, meaning I'm going to plug in g into f. So, f is x minus 2, but now I want 5x plus 2 in place of it, minus 2 over 5. What can simplify? My 2's can cancel out. I now have 5x over 5. My 5's go away, and I'm left with just x. That's what I need to get for both fog and goth, as we would call it, f of g and g of f. Same the other way, when I plug f into g, I should have 5 times the quantity x minus 2 over 5 plus 2. This is g with f inserted into it. Okay? What happens? Same thing. 5's go away. I now have x minus 2 plus 2, which is just x, because my 2's will cancel out there as well. Alright, in this one, you can do the same thing. Let's start with f of g of x for 1 over x. So, I have 1 over instead of 1 over x. I want 1 over x. I'm just plugging one into the other. Remember, that's the same thing as saying 1 times x over 1, because I'm going to divide by a fraction, the same as multiplying by an inverse, while 1 times x divided by 1 is just x. That's all I need to do. Because, well, the functions are the same. All I have to do is to do the exact thing. That's the same as g of f of x. So you don't even have to need to do it twice for that one, because it's just that simple. Alright, the next one, third one here, is the most difficult out of all these. So f of g of x, so I'm plugging in g into f. So I have 1 over 1 plus, but instead of x, I want this 1 minus x over x. I need to make a common denominator down here. So I'm going to make this 1 over, this will be x over x plus 1 minus x over x. So I have 1 over x plus 1 minus x over x. What do you notice happens? Well, this x plus 1 minus x, I have 2 x's there, one's positive, one's negative, so they go away. I have 1 over x. That's the same thing we had up here, where we could invert and multiply, and that'll give me just x as a result. A similar thing happens when I do g of f of x here. When I do this one, I'm going to plug f into g. So I have 1 minus, instead of x, I want to plug in f of x. So 1 over 1 plus x. And my denominator here is x, which is 1 over 1 plus x. Same way, I want to make a common denominator. This denominator would be 1 over x. Or 1 plus x, I mean. So 1 plus x over 1 plus x minus that 1 over 1 plus x all over the fraction 1 over 1 plus x. It looks ugly. It really is ugly. Not much we can do about it. Let's try to simplify up here. I'll now have 1 plus x minus 1 all over 1 plus x. This denominator is still 1 over 1 plus x. Simplifying that more if I can, well, again, I have 1 plus 1 minus 1, so that goes away. So now I'll have just x up top over 1 plus x. And now, instead of dividing by the fraction, I'll multiply by the inverse. So times 1 plus x over 1. Same thing as before. Notice I have a 1 plus x up top and on the bottom. They cancel each other out. And that leaves me with just x as my answer. Alright, and now for this last one. I'm going to do first f of g of x. When I do that, I should have plugging g into f. So that means instead of x squared, I have square root of x minus 4 squared plus 4. Well, the square root and the square will cancel each other out like we've done before. And when I do that, I should now have just x minus 4 plus 4, which is the same as x. because the minus 4 plus 4 cancel each other out. Same thing when I do g of f here, g of f of x, I'll do the same thing. I'll now plug f into g. So I'll have the square root of, instead of x minus 4, I want x squared plus 4 minus 4. Again, very similar. The plus 4 minus 4 cancels out. I have the square root of x squared. Square root of a square, they go away. I'm left with just x as my result. Okay? Now on to step number 3, finding inverses. Again, very straightforward. All we're going to do, remember this means the same as y equals 3x plus 5. All we're going to do is change y and x to make it x equals 3y plus 5, and now solve for y. Do that by subtracting 5 on both sides. And then for this one, I need to divide by 3. X minus 5 over 3 equals y. Now I want to say proper notation, so this is x inverse of x equals this thing. X minus 5 over 3. Looking at part B here. Same thing. I have the cubed root of x minus 1. What I'm going to say is now I want x equals the cubed root of y minus 1. And let's undo this whole thing. I first need to cube both sides. That will get rid of the cube root. Equals y minus 1. Add 3 to both sides, or add 1 to both sides to get this. So this is x inverse of x equals x cubed plus 1. Part C. X equals 3y plus 4 all over 5. To get this by itself, I need to first multiply both sides by 5. That'll give me now 3y plus 4 when I do that. And then solving for y like we've done before, subtract 4 from both sides. Minus 4 equals 3y. And then now I'll divide by 3. So 5x minus 4 over 3. That's what f inverse of x will equal. And the last one over here, I have x is equal to y cubed plus 1. I need to start by subtracting 1 from both sides. That gives me y cubed by itself. Now, taking the cubed root of both sides gives y by itself. So that means this is what it equals, and that means we're going to equal, call it f inverse of x. Alright, and on to the final, graphing the inverse. All we want to do for these, if the white function here is our inverse, remember, the inverse function is just a reflection over the line y equals x. So I would draw this little dotted line, diagonal line that looks like y equals x for each one first. And then from there, look at if I were to fold this side of the graph over to the other. Fold it over that dotted line, what would I get? It would look something like this. We should always be pretty much equidistant from each other. Actually, it should probably be a little bit further down, maybe something like that, in terms of it folding it so that it's the exact same distance no matter where I go. Now this one right here, see how it crosses the line in 2 different places? That means that my inverse function also should cross at those places. And it's kind of tough to tell because we haven't talked much about it. But essentially, as this goes down, it's getting further away. That means this should be going further away out this direction. Now it should kind of come in, kind of hook back up like that. And notice, again, it connects at all 3 places. And that as one moves away from the line going up, the other one goes out. Again, this is a rough sketch. It doesn't have to be perfect. But mainly I want to see that you're understanding that I should be flipping it over that line. Well, there you go for combinations, compositions, and inverses. And hopefully you'll be in good shape and ready to make this test happen.